And hello, welcome to this video. So in the last video, I went into extensive detail of how this IXmlLibrarySelector was done, and I probably won't do another coding series as extensive because the methods I use to code the rest of these classes are pretty much the same as what you saw in the IXmlLibrarySelector, where I actually look at this mind map. I will try to implement the methods and everything within this mind map, and that's where I go from. I will usually code the interface first, then I code the test second, then after I code the test, then I code the after playing around with the test file and testing individual bits of code, then I'll code the implementation the last, then assert the test. Then after that, I'll consider that okay, done, test-driven development complete. And then I'll move on to the next interface and class. So here's the IXmlComponentList, which I have. So let me show you that thing, IXmlComponentList. I'll quickly show you how it's done as far as possible. Then we can move on to the next video. All right, can you see this IXmlComponentList? I mean, it's kind of a misnomer. It's not really a list we are doing here. What I have here instead of a list is IEnumerable. Okay, let me open this thing on the right hand side. Oops. Oh dear. I just undo. Okay, quit all. Oh, caps lock. I got caps lock. Undo. Quit all. Alright, there you go. That was not as expected, but yes, let's go. This is kind of a misnomer. As I said, this is not IEnumerable. I mean, it's not a literal list I'm giving back. I'm actually giving back an IEnumerable. Okay, so you supply a desired library as string, and what you get out is this IEnumerable of string. So this is a component list. Okay, right here, I'll of course have tests to go with that, which I'll open up. Okay, so first I have this interface, and you can see the interface actually kind of fits the inputs and outputs. I want the input of desired library. Output, I want a list of components, IEnumerable of string. So if you go to the go 10 up, I'll open this. Oops, I don't want this one. Let's go open here. I'll open the test for the IXmlComponentList. Right, so here's what the test looks like over here. Let me quit this, exit this terminal. I'll split in two. Alright, so over here I have the usual things again. This is the second part. Okay, I've coded the interface. The next thing I code is a test. Okay, the test here is to return all components of dwsim.xml. Okay, use some deep equals to inspect. Okay, what is deep equals? Okay, well, it's not a method I actually use, but it's a good method for anything in XDocuments. For XDocuments, this deep equals actually compares the values of the two XNodes. Okay, what is an XNode, right? If you take a look at what XElement is and XDocument is, okay, so look at the XElement. Okay, XElement actually is a type of XNode, as you can see here. XNode is this generic class. XElement actually inherits from XNode, and of course, if you take a look at XDocument, XDocument also inherits from XNode. Okay, XDocument also inherits from XNode, as you can see here. So you can use the deep equals method. It's a static boolean, so you just call the deep equals method by typing xnode.deepequals, and this will help you compare two XDocuments manually. Okay, but we are not going to do that. I did not use that because we are comparing IEnumerables, not XDocuments anymore. Okay, the way I compare two enumerables is to use the SequenceEqual method. Okay, so before you get confused, what's the idea here? I'm returning all the components of dwsim.xml. Okay, first method is me using regular code. So how would I return a list of elements? How would I return a list of elements in dwsim using manual code? So this is what you'll see here. Okay, I will scroll through the lines and explain line by line. Okay, line 63 where my cursor is, and let me go to the left hand side. I will ls and I'll get the buffer 2. Okay, so just pay attention to the right screen first. Okay, so first thing first, I load my IXml library loader. I get my XDocument. I load that XDocument. I start making this reference component list, which is a list of string. I make a new list of the string, and then what I do next is I add the element value, which means over here, right here, you'll see actually these are the components. Okay, these are the components which I add value by value of the names of each component within that XDocument. So this for loop actually does that. You can take a look in your own time. I'm not going to explain as much. So what happens here is that yes, this reference component list is a list, but to compare one IEnumerable to another, I need to change this reference component list into an enumerable. So this reference component enumerable is an IEnumerable of string. Okay, and this reference component enumerable will just be set equals to reference component list. However, reference component enumerable will strictly be interacted with using the IEnumerable interface, so it will have a more restricted set of methods as compared to the list. Okay, so I'm going through very quickly roughly what happens. Then after that, I make an IEnumerable of string, and I get my IXmlComponentList object. Okay, and what I do with this IXmlList component object, okay, this is the list component object. Okay, this will be a new XmlComponentList v1. This is the new class that we are making, or I have made. So this is the implementation, XmlComponentList version 1. And of course, actually, what is needed is that this XmlComponentList version 1 will need a IXmlReader. Okay, this is dependency injection. So over here, I do dependency injection. I make a IXmlReader, and then I make this new IXmlReader, and I do a dependency injection into this XmlComponentList. Okay, I assume you know what dependency injection is, so I will not do it again. So once the dependency injection is done, then what I'll do is I will execute the getComponentList method, okay, which I have defined here in my IXmlComponentList. What do you call that? IXmlComponentList. I've defined here this method called getComponentList. Okay, and this will be loaded into the test component enumerable, which is over here. All right, and then I will start having a test, and this test is to see whether both lists are equal. Okay, so list equal is this variable that I check it as a boolean. Okay, so list equal equals to enumerable, SequenceEqual, okay, reference component list, and test component list. Okay, so okay, so this is not what we are using, but enumerables are equal. Okay, SequenceEqual method. Yeah, we use the enumerable SequenceEqual method to see whether two enumerables are the same. So this is the method I'm using to test for equality, and this will return a true or false value, which is a boolean, and then I can use the assert method. Okay, assert true or list equal. So this is the first test I ran through. Okay, the first test I coded to run it through. So of course you can see that the test, if I run .NET test, okay, I mean I won't be presenting to you if I have not run .NET test. So I have run .NET test. Okay, so .NET test. So you can see obviously everything is running okay. All right, these are of course some new tests that I'm doing for now as I'm developing the next part. So just ignore them. But for now, all these tests are okay. Pass, all the tests have passed. So that means these tests have passed as well. So you can see the flow of logic. I'm preparing a IXmlReader list, okay, IXmlReader reference list, so to speak. And then I compare that with the get component list method over here, and then this will be this method that I implemented here. When you try this first before you code anything, it will fail, so keep tweaking it until it succeeds. And the nice thing about doing it, okay, over here I make that list manually, okay, versus here I do it within a method. So the good thing about doing the test first is that you get to see how the thing is done manually. And once you see how the desired object or the desired variable is generated manually, you can pretty much copy and paste this code right into your implementation right here. Okay, you can pretty much do that. All right. So all this code here actually. If you already find that you generated the right list, you can if you generated the right list in the test section, you can pretty much copy and paste this same code here into the method that you want to implement. Okay, so test-driven development, you're not adding too much extra work, because with the work that you do to write the test, okay, write the test properly, it's most likely the method that you use in your code anyway. Okay, these are the same few lines of code you will write in your code here anyway, and that will guarantee that it's successful. So you actually do your fiddling around in the test file, where you have fact test or theory test, whatever. Okay, you do your fiddling around here. Once it's okay, you found that the code works, then you copy and pretty much paste this code into the functions here. So that's how I do my test-driven development. Okay, so let me go back and let's check out how this get component list thing actually works. So as I said before, we actually have dependency injection, and that is evident within the first few lines, where I need IXmlReader to be dependency injected into this IXmlComponentList. So there is this loose coupling setup here. Okay, there's this very loose coupling setup here. We have a IXmlReader, and this IXmlComponentList version 1 will be dependent on this interface rather than on the concrete. So this the concrete thing. So there is a proper dependency injection mechanism right here to initiate the thing, so that we have a IXmlLibrarySelector. From the IXmlLibrarySelector, we can take in a desired library and output the desired take in the desired library as a string and output the desired library as an object. So that's actually the first few steps. Okay, I dim XMLLibraryLoader as IXmlLibraryLoader. Okay, and then over here I have this semi-complicated catch statement. So just ignore the catch statement first and pay attention to this part. Okay, you see XMLLibraryLoader equals me.XMLLibrarySelector get XMLLibraryLoader, and the desired library here, right here, is the string that you actually supply here. Okay, so the catch message, the catch things, I will come back. So after this, after returning the XML library, I load the XDocument. I declare XDocument variable, and I load in the XDocument over here. Again, this part over here, just ignore first. Okay, and then I make a new component list as list of string. So you can see how similar the codes are here. You see, in line 15 here, component list as list of string is pretty much the same as reference component list as list of string. I just changed the names. So pretty much the code I wrote here, I just copy and pasted it here, and I made a few more edits for various reasons. So okay, we built the new list here, and you can see that this line here I did in my test is pretty much this line here which I did in my function. Okay, and you can see that the code is almost identical. And then I have a next. Alright, and then once I'm done, I return the component list. Okay, now there were a few things I added. Alright, there are two things I need to think about. First thing is exception behavior and memory management. So okay, the memory management bits, as you can see, these are here. I put as a comment here, memory management to delete XDocument. Alright, so I clean up the XDocument even before I return the component list. Okay, this is just me being very judicious. I want to make sure my memory is cleared. Okay, so this come under memory management steps 1 and 2. So this is the second step actually. XDocument is equal to nothing. Let me bring you to step 1 of the memory management. Okay, memory management step 1, okay, is for me to dispose of the XML library loader and delete it immediately after we are done with the XML library loader. So you see this XML library loader, the whole point here is just to get this XML library loader to load the XDocument. Once the XDocument is done, once the XDocument is loaded, I don't need this XML library loader anymore. So I will just free the memory by calling the dispose method and setting it to nothing or setting it to null as for C#. So these are the two steps of memory management. Okay, everything else, all the other objects I still need, so I will not do anything else with it. Okay, the last one is exception management. Okay, you want to think about exception behavior. Okay, so ZZ, exception management. Okay, so what's exception management? It means that, alright, if I want the program to behave such that if I supply a wrong name, a rubbish name for the what do you call that, XML library, I should expect an error message. So this is the part where I have this error message. Okay, so I'm going to try XML library loader, get library loader. Okay, if something goes wrong, I have an index out of range exception. And what this is saying is that the library name you provided is gibberish. Okay, so what I do here is I'll make an error message. This error message is a string error message. I will actually put in the interface and implementation where this was called IXmlComponentList, XMlComponentList version 1, and then I will just add the exception message straight to this string here, and then I will throw a new index out of range exception. So I will still throw the exception. I'm just modifying the message over here so that I don't I know where this message is coming from. I know which classes are kind of wrong, okay, kind of going wrong. So this is why I have this try and catch blocks over here. These are actually to deal with exceptions. So I'm pretty sure you've seen try and catch blocks already. If not, okay, try catch Visual Basic. Right, so try catch finally statements are here for Visual Basic. There's a similar one for C#. In fact, C# they will have a lot more documentation. Okay, so these are the features of this code. Okay, and of course the last part is that, well, I have a finalize. Okay, this is also for memory management, which is the destructor or finalizer. Okay, I set the IXmlReader selector to nothing. So if you go to the front part, Yes, this is the IXmlReader thing which we did dependency injection on. I want to make sure it is set to nothing if the finalizer is called, so that all these things will be deleted properly. Okay, so I guess good habits, if you declare objects, delete the objects. Make sure it's all deleted. Okay, I mean the garbage collector will kind of do the job for you, but this is just making memory management, taking it into your own hands and having a little bit more fine control. Okay, not always necessary, but I guess it's a good habit, especially when C# allows you to manage memory in that regard. So this is the memory management bit. Okay, so I actually have 2 more tests actually. One is over here where I have IXmlComponentList exception message manual. So I just what happens is that I supply a gibberish library, a gibberish string name for the library, and it will throw the exception message, right? It will throw the exception message, and then I just wanted to see whether this exception message was correct. All right, so I'll go up and I'll show you this one. Okay, so this part here which I'm highlighting. All right, so what this here is that I'm actually performing the same test, except that I just do an assert throws to make sure that I'm getting the right exception. I'm getting the right exception, which is an out of range exception. Okay, if I actually supply a rubbish library, I should get an index out of range exception, meaning to say this library that you requested doesn't exist, so please use another library. Okay, so this is what all these tests are about, and this is how the IXml this is how the IXmlComponentList class or interface should behave along with its interface. Interface should behave along with its implementation. So the dependency injection is there, so it should follow most of the solid principles good enough for the time being. So it's very loosely coupled. We shall leave it as it is. Okay, so moving on. Okay, I've already found that yes, this IXmlComponentList, we are pretty much done with it. So this dependency branch is done. I'm actually going to move on to the next thing, okay, which is IXmlReader. So this is the code I'm actually currently coding now as of making this video. Okay, IXmlReader. What does IXmlReader? What is it supposed to do? It's supposed to you're supposed to supply a fluid type, a desired quantity list, and it's supposed to return you IEnumerable of engineering units quantities. Okay, the dependencies here are the engineering units NuGet package, right? So I've started coding this bit already. Okay, and what is IXmlReader supposed to be dependent upon? We have the library selector class here. Okay, library selector class is this one. Okay, library selector interface, pardon me, is this one, and then we can perform dependency injection. I have an IXml quantity retrieval, which actually will give us IEnumerable. Okay, this thing here will actually give us IEnumerable of double or string. Okay, this will actually give us IEnumerable double or string. Okay, I may actually give it one more output later on, because there's a problem I saw that actually makes the code structure a little bit more complicated. Okay, but IEnumerable or string. Okay, so this thing is supposed to search for the XML libraries and just give you back the double. Okay, and then of course the last bit. Okay, let me do here, zoom out a little bit. Okay, so the last thing is the unit converter. Okay, which kind of brings me to my next point. We need to understand how this engineering units thing works. So that will be the subject. That will be something to study later on. Okay, so we'll need to understand how this engineering units NuGet package works eventually. All right, so this is a class overview for the next part. Okay, one thing to note. One thing to note about this. Okay, this my maps here is a little bit off. The dependency should actually say which interface that is, but anyway, this IXmlLibrarySelector actually is quite interesting right here. Okay, IXmlLibraryList to be more specific. This IXmlLibraryList actually you actually can supply a string inside. Okay, or rather IXmlLibrarySelector. Okay, IXmlLibrarySelector, you can just input in your desired library and it will give you a concrete class of IXmlLibraryLoader. Okay, and the implementation here is XMLLibrarySelector May 2022. Okay, and this is a good example of, or rather, is one example of me attempting to implement open-close principle. So go to the library selector, and I'm going to vim star this one. So you can see that the interface here is very simple. Get XML library loader, supply a string as a library, and it will give you the IXML library loader object, or the object that fulfills that interface. Okay, how does it do it? Okay, so over here I don't really have dependency injection over here. I kind of manually make it, but all right. The thing is that I have this okay, I have this for each statement right here. Okay, so what do I do? Okay, this IXmlLibrarySelector will interact with this IXmlLibraryList, and this library list will have a tuple, will be a list of tuples. All right, it's an actual list. It's a list of tuples. Okay, and the tuple is of the type one. The first type is string. The second type is IXmlLibraryLoader. Okay, so that you can actually, if you want to find a library and you have multiple libraries, right? If you want to find a library within this tuple, all right. So I have this library list right here. Okay, library list equals XMLLibraryList return XMLLibraryList. So this library list is actually a list of. Let me open up a directory, library list. Get this open. Okay. So this library list, okay, this library list is basically, well, it's a list of, you know, string values, okay, and then you have objects that fulfill or implement the IXmlLibraryLoader interface. For example, DWSim XML brute force. So whenever I key in DWSim, okay, this for loop here will actually search through the list and then compare whether the first part of the list, the first string of the list, is actually the same as this DWSim. Okay, if it's the same, then of course we will return the library. If not, throw an exception. Okay, so this is one good example of me trying to implement the open-close principle. So it means to say open to extension, close to modification. All right. So the thing is that, right, if let's say I coded this for loop as a case structure, all right, then I will have to check for each element inside that. Yeah, if I've coded it as a case structure, and then I will probably have to check to see. I have to have a lot of if loops. If I have 5 libraries, for example, I will have to have. If I have 5 libraries that are available for selection, I will actually have to code 5 case structures to check whether, you know, the string matches the library name. Okay, over here. So if else if, else if, else if. That's one way of doing it. The second, of course, is case structure. But every time I add a list to this library, okay, that case structure thing will have to go longer and longer. Okay, so the way to circumvent this is to, at least for me, to keep the code short and neat, I use enumerables. Okay, I use enumerables so that I will actually cycle through every single element in the enumerable, and I'll run over here an if loop. Okay, I'll run the if loop here and check whether the names actually match. Okay, so that as this list grows longer and longer, I only have to add one line of code here, okay, in the constructor of the IXmlLibraryList. Okay, I make a new list, and then I keep adding libraries to this list, and I attach a string right there. For example, ChemSep1, ChemSep2, and all the other libraries. I can keep adding and adding them. Okay, and I will not even have to change. This code right here. Okay, so this code, IXmlReader is close to modification. Okay, but I can actually supply longer and longer lists of the XML library and the matching strings so that I can perform this selection function of the appropriate XML libraries as I want. Okay, without having to extend or change this code with longer and longer if loops or case structures. So this is one way we can, one amateur, I guess, example of open close principle, where I have this code is close to modification but open to extension. All right, so that is it. Okay, so anyway, just wanted to make a note of that, and I'll stop talking. I'll see you next time. Bye bye.